Hello everybody. In chapter 8 we're going to learn about external direct products. This is a way to take groups and piece them together to create bigger groups by taking ordered pairs. So let's look at the definition. If we have two groups, G1 and G2, then the external direct product of G1 and G2 is given by this notation right here, G1 with that circle plus G2, and it's defined just as the ordered pair of elements AB, where the first one, A, comes from our first group, G1, and the second one, B, comes from our second group, G2. And the operation in this new group is performed component-wise. So if we are applying the operation to AB with CD, then we use whatever operation is used in G1 to combine A and C, and whatever operation is used in G2 to combine B and D. So this is done component-wise. And this is something that these external direct products, you have seen examples of it. So for example, R2, you can view it as a group under addition as the external direct product of R with itself. So if the operation is just addition, then our two-dimensional space, you can view it as the external direct product of the reals with themselves. Okay, now we can do this with more than just two groups. We can do it up to n groups. And so our note says if we take more than two groups, so we have G1 through Gn, then the product of G1 all the way through Gn is defined exactly the same way. So just instead of having two components, we have n components. Let's look at an example. And the example that we are looking at is in example 1, Z2 plus Z3. What does that group look like? Well, and then we want to know what's the identity in this group? What's an inverse of an element? Is this group cyclic? So we will ask the similar questions that we have asked when we've seen just single groups before. We will now ask about this external direct product. So first, let's see what's in it. So if we are looking at Z2 plus Z3, what are things that are in there? Well, they are all of the form something, comma, something. And the first something comes from Z2 and the second something comes from Z3. So let's see what's in there. Since 0 is in both Z2 and Z3, 0, 0 is certainly in there. And then Z2 also has 1, and so we also have 1, 0. Now there's really nothing else in Z2, 0 and 1, but in Z3 we can have a few more things. So we can combine 0 also with something else that's in Z3. So how about 1? And we can then take 1 and 1. What else do we have? Z3 also has 2 in it. So we also have 0, 2 and 1, 2. And I think that's pretty much it, since there are 2 things in Z2, there are 3 things in Z3, so really we got everything. We have 2 times 3 elements total. So here is like our first little result. If there are 2 things in Z2 and 3 things in Z3, then we have 2 times 3 elements in Z2 plus Z3, and this certainly this generalizes to bigger groups. What is the identity? Well, since the operation in Z2 is addition, the operation in Z3 is addition, our identity is 0, 0. The identity in Z2, comma, the identity in Z3. And we can convince ourselves that this is really true. So if you're taking 0, 0 and you add it to anything, you are getting that anything back. And the same thing happens if you add 0, 0 from the right. So 0, 0 is our identity element. Inverses. What is the inverse of 1, 2? Okay, Let's see. So it's something that we have to add to 1, 2 to get 0, 0. And what does that? Well, so the inverse of 1, 2 is 1, 1. Because when we are taking 1, 2 and we are adding 1, 1, and all of this happens mod 2 and mod 3, we get 2 mod 2, and we're getting 3 mod 3, but that is 0, 0. So the inverse of 1, 2 is 1, 1. Now the last question we wanted to investigate was, is this new group Z2 plus Z3 cyclic? And what do you think? The answer is yes. And the easiest way to figure out if something is cyclic is by finding a generator, and the generator is 1, 1. And we can convince ourselves by just writing out the elements. So we have 1, 1. If I add it to itself, I get 0, 2. If I add it to itself, I get 1, 0. If I add it to itself, if I add 1, 1 again, I get 0, 1. If I add it to its, if I add 1, 1, again, I get 1, 2. If I add it again, I get 0, 0. And let's see, that's 1, 2, 3, 4, 5, 6. Yep, that indeed is everything. So we've shown that this is Z2 plus Z3. And so therefore our group is cyclic.